Hello students, this video is designed to help you with the problem sets from the first couple of lessons in Unit 1. We're talking about undefined terms, looking at line segments and partitioning them, and also looking at the equations of lines. Let's get started. Take a look at the first problem set, that's the Lesson 1 problem set. Pause the video and try to answer these questions, and then come back when you're done. Alright. The first question asked you to draw and label geometric figures. The first angle was angle DEF, and it's important to know that the middle letter should be that vertex, that point that's in the middle. For the second one, line FG, it just needs to be a straight set of points that extends infinitely with arrows on both sides. As long as it passes through 2 points F and G, you should be fine. Line segment PQ, P and Q just have to be points on this line segment, and it is a straight set of points, but it does not have arrows. It does not extend infinitely. In both cases, it doesn't matter what order you put the points in. For example, this could have been G and this could have been F. It's still considered to be line FG. Line GF is synonymous with that. However, with ray AB, it is 100% necessary for A to be the endpoint. So here we have one endpoint and one point that it passes through on the way to infinity. So make sure that this second letter, B, is the letter that corresponds to where the arrow is. For number 2, it asks us to explain the difference between a line and a line segment and then provide an illustration for each. All you have to do is draw a line and a line segment. The thing that we were trying to get across to you here is that a line extends infinitely in 2 directions. It has arrows at the ends. You can't measure its length either, which should make sense to you because it is infinitely long. So its length is literally infinitely long or infinite. Whereas a line segment, it is finite, F-I-N-I-T-E, which means it stops here and it stops here. It does not keep going. So you can measure its length, and we do measure its length in geometry with the distance formula. Alright, moving on to the next page on Lesson 1. Pause the video, see if you can try to answer these questions, and then come back to check your answers. Alright, we were told that A, B, and C are collinear. Collinear means they're on the same line. One important thing to note here is that this line segment is made up of 2 smaller line segments. It's made up of AC and CB. And we know that AC plus CB should be equal to the entire length, which is AB. That's something that we use, that's a fact that we use in all of these questions. For example, in letter A, it says AC is 5 inches, CB is 3 inches. Find the length of AB. Well, we know that AC plus CB equals AB. This is a fact. Once we know this fact, we make it into an equation. We substitute in the numbers. We know that AC is 5. We know that CB is 3. So all we have to do was solve this equation for AB, and AB is 8 inches. In order to get full credit for this, you need to write the units. For question letter B, AC was 6.25 and CB was equal to 3.5. Very similar. We substituted that into the equation, and we found the answer for AB. In the third one, in letter C, we were given BC, which is 3.7 centimeters, and we were given the entire length of the line segment, which is AB, is equal to 10.2. We were asked to find the length of AC. We're using, if you look back, we're using the same exact relationship. AC plus CB is equal to AB. However, we don't know AC this time, which is okay because all we need to do is use our equation solving skills from algebra. We subtract 3.7 from both sides, and we should get 6.5. And then for letter D, we did the same thing here. We subtracted both sides by 3.25 in order to get 1.5. We just solved for the missing information. This is very similar to algebra. For number 4, hopefully you got all of these geometric figures. There were points, segments, rays, lines, and angles. One quick note about the lines. All of these different names for lines, line AB, line AX, line XB, they are all the exact same line. They're just the line that passes through those 2 points. Sometimes you'll see, or most of the time you'll see, a line labeled as BX instead of XB, only because alphabetical order is generally observed in geometry, but it's totally legal to call it XB as well. There are 4 points, there were 4 segments, from A to X, that short segment, from B to X, this short segment, from X to Y, this short segment, without the arrow part, obviously, and then from A to B, which is a combination of AX and BX. The rays are important in terms of their direction, because if we have from A to B, that's starting at this point and traveling this way, whereas let's see, from B to A is starting at B and traveling in this direction, right? the order of the rays are important. Let's see, last piece is the angles. I know AXY is this angle here. I know that BXY is this angle here. AXB is actually a special type of angle. AXB is called a straight angle. It's an angle with a vertex that is collinear with both of the other points. So in other words, AXB is an angle, but that angle measures 180 degrees. We're going to be talking much more about angles later on in the course. All right, moving on to lesson 2 problem set. Pause the video and make sure you answer these questions, and then come back to see if you got them right. Lesson 2 was all about finding the length of line segments, and you're using the distance formula. To be honest with you, this lesson is all about exercises. You need to make sure that you know what you're doing with formulas like this. You need to just make sure that you've practiced it several times and you know the ins and outs of it. You label the points, you substitute them into the formula, and you use your algebra skills. A couple of quick notes. Once you get whatever number is in each of these parentheses, you square it, which does not mean multiply by 2. You multiply it by itself. It's a common student error, for example. Some students would put, 6 squared, they would put 12, but 6 squared is 6 times 6, which is 36. Another common error would be if the number inside of these parentheses was negative. It doesn't matter whether it's negative or positive. When you square a number, it becomes positive. There's an example of that later on. Here's the slope and length. I'm not going to talk too much about slope because you learned about slope in algebra, and, well, you should remember that. But the slope formula is presented here. For number 3, this was a situation in which there was a square root that could be simplified. We simplified this radical. In other words, we looked into the square root of 136, and we tried to find the largest perfect square that fit into 136. And the largest perfect square was 4. I know the square root of 4 is 2, but I don't know the square root of 34. It's a number that it's an irrational number. So we leave it as 2 radical 34 as our answer. Going back to the previous example, it did ask for the nearest tenth. So in this case, we took the 25,000 and we square rooted it to get 158.1. For m, which is equal to 1/3, well, we didn't give it to the nearest tenth. So what would the nearest tenth be? You guessed it, 0.3. I know that 1/3 is 0.3 repeating, but if we're asked to round to the nearest tenth, it looks like this. One other thing, you can see the squiggly lines here, the squiggly equal sign, that means approximately equal to. It indicates that we have rounded somewhere. For number 4, it was very similar. We had a situation where we had 2 points. We named them x1, y1, x2, y2, and substituted them into the distance formula. In this case, we didn't have to do any simplification of radicals because the square root of 625 is an integer. The square root of 625 is just 25. All right, moving on to lesson 3 problem set. Pause the video, check it out, see if you can get it right, and then come back and see if the answers are correct. For lesson 3, you could have used 2 different methods. In this case, I used the graphical method only because they gave us this beautiful graph to work with. It's telling us that these are the endpoints, which we graphed on the graph here, and it asks us where point E is if the ratio is, for example, 4:1. In order to figure out a 4:1 ratio, here's what I did. I know from D to F here, I went up 2 and over 3. The slope is 2/3. 1, 2, 3, 4, 5 times. If I did that procedure 5 times, that means it's very easy to split it into a 4:1 ratio. All I have to do is make sure that 4 of those slopes are on the left-hand side, and 1 of those slopes is on the right-hand side. Now that I know the split, I know the point that I'm looking for is right here. That point is, of course, 6, 5. However, the next question asks us, well, how do I do it so that there's a 3 on one side and a 2 on the other? Well, I just look for the slopes. There's 3 slopes here and 2 slopes here. Again, I could just figure that out as 3, 3 just by looking at the slopes. I'm not going to show you the next step because it's exactly the same as the previous steps. It asks what the midpoint is, and you could have found it graphically if there was an even number of slopes on both sides, but there's 1, 2, 3, 4, 5 slopes total, so the midpoint is going to be here somewhere. It's not an exact integer for both x and y. So we use the midpoint formula. It's a fairly straightforward formula. Please remember that it is a plus in the middle here, not a minus. You should get 1.5, 2. 1.5, 2 is here. which makes sense because that is just about where the midpoint should be. For question number 2, it asks us to find the points on the line segment, but it doesn't give us a graph, so we're forced to use our partition formula. Take note of all the parts of this partition formula. We have the ratio of 1 to 3. That means the 1 is A substituted for 1, A substituted for 1, and B is 3. Eventually, in the formula, it's going to take the form of whatever the first number is divided by both of those numbers together. So 1 divided by 4 is what you get. You also know that you're always going to start with x1 and y1, so that's going to be -3 in this case and 0 in this case. The rest of it is just substitution, and you should get 2 different values. The first one is going to be your x value, and the second one is going to be your y value. Good idea also in an answer to state your answer. The points coordinates are -1, 2. Same procedure here, just another practice problem to make sure you know how to use these formulas. Sometimes these formulas will give you a decimal. They might give you 12.5, or they might give you 6.3 or something like that. It's okay to get a decimal for these numbers, but most of the time, the Regents writers will give you a nice integer to work with. Moving on to lesson number 4, this is the last lesson we're going to go over. Pause the video, try to make sure that you give it an attempt, and then see if you got it right. All right. The first answer is letter A. The equation of the line that passes through the y-axis at 0, 8, that's the y-intercept, and then it gives you the slope, -2/3. So I can observe that this has the wrong slope. This is +2/3. This slope is 8. It's not -2/3, and this slope is correct, but the y-intercept is wrong. The y-intercept should be 8. So this is the only equation that gives us both correct values. In this case, it gives us the points rather than a slope and a y-intercept, so we need to find the slope using the slope formula. This should be a procedure that you know how to do by now. And then the y-intercept is simply taking the slope-intercept form of the line, substituting in the slope, and also the x and y from one of these points. I didn't choose this point because it's got a negative in it. I chose x from here and y from here. All right, for number 3, I found the slope again using that slope formula. I found the slope to be 3. And then I selected one of the 2 points here. I selected the one with no negatives again. Here's my x and here's my y, so that means here's my x and here's my y. If I solve this, I get b is equal to 1, which means my y-intercept has to be 1, and my slope, as I said before, has to be 3. Once you find the slope, sometimes it's a little easy to take that information and do a little elimination, so that at the end of the test, let's say you're running out of time a little bit, you have more of a chance of getting the correct answer by eliminating the ones that can't be the answer. For number 4, I extensively wrote out all of the steps that I needed to take. These are the same steps that we got on the notes in class. Find the slope. In this case, it was 4/5. Not a nice, easy integer, but 4/5 is better than saying 0.8 because 4/5 tells us the rise, and it also tells us the run. So I preferably keep the slope in fraction form. Then I found the y-intercept. In this case, it was pretty straightforward to find the y-intercept because, well, they gave it to us. 0,7 is the y-intercept. But when you substitute it in, you find out that b is equal to 7. If you didn't observe that this was the y-intercept, you still could have gotten the answer. That might have been just a little shortcut for you. And then for question for step number 3, you write it in slope-intercept form by identifying the slope and then the y-intercept. For number 5, it asks for the equation of the line that passes through this point and then is parallel to this line. Parallel means it has the same slope. So my first step to find the slope was very easy. It already gave it to us. Find the y-intercept, write the equation. Last but not least, here's the last page of this problem set. Pause the video, try to see if you can get it right, and then check your answers. It asks for the slope and intercept of this line. It's not in slope-intercept form, but it can be if you use your algebra skills. Y minus 4 equals -5 times -x plus 2. All you have to do is do the distributive property here, and then move the -4 to the other side. We got the slope and the y-intercept very easily. In order to find 2 points that line the line, we could do a number of different procedures, but my favorite way to do it is to find an x-intercept and a y-intercept. That's by substituting in y equals 0 and x equals 0, an easy way to do it. Then for the last one, it asks if these points are collinear. Collinear means lies on the same line, so we first figure out whether the slopes are all the same, then we find the equation of one line, and then we determine whether the third point is on that line. All right, this video was designed to help with Unit 1. Good luck studying.